Hello friends, welcome to this channel. This is G Solutions, where we find solutions for your needs. Okay, so we are still in the fully paced system, and fully paced system is actually a number of single phase. So when you multiply single phase to n or a certain number, it will be a polyphase system. Poly means many. Okay, so we can connect actually the phases to two types, like star connection. So we can connect the phase or the phases into a star connected system. We use the word star here because we can still add a phase here, but I have shown to you in this drawing that there are 4 phases here. Okay. So we have already known that the coil here represent a source or a load. It can be a generator because the generator is composed of coils, and it can be represented like this one. Okay, but sometimes you can also use the one that we are using, a circle, and inside of that is a sinusoidal signal, which is for our source. Okay, but we use this one to gives us an idea that what we are dealing with here is a generator. Okay, now if your current actually goes out from this point going to here, okay, and we can name this as, since it is passing through this coil, by the way, the voltage at this coil is B sub P. I will write B sub P for every coil here, which means that this coil is producing a what we call a phase voltage. So B sub P for our notation is, this is for phase voltage. Okay, so here you can see 4 phase voltages, and the current is going from this point and passing through B sub P, and we call this as I sub P. So the current that passes through your phase voltage is the phase current. So we have here phase current. Okay, and when this current is in these terminals, so you have here 4 terminals, and it comes to this point, that will be I sub L. So I sub L is for our line current. So it is clear now that the letter that we are using, okay, this one stands for the line current, and P stands for the phase currents. And the voltage at this point, we have a voltage there, okay, and we also call that as B sub L. So therefore that is the voltage in the line, or the line voltage. Okay, so this is the representation of sources, or what we call, you connect it into a star connected system. Okay, and one thing that we should know is that this phase voltages here is displaced at a certain angle, and thereby it is giving us an impression that the voltages here is displaced in an angle which is the same. Okay, so it can maybe divided by 360 degrees. So because one rotation is 360 degree, and if you have 4 phases, it can be divided by 4. Yeah, so the angle is equally divided, and therefore we introduce also here an angle, theta. Okay, that will be the power factor angle, and if you are to get the cosine of your theta, this is the power factor. Power factor. It can be a load, the power factor of your load or your source. Okay, and so these are the things that I think also the letter N, we can have N for polyphase or the number of phase. This will be for the number of phase. So these are the notations that we are using here. Now if you are to solve for B sub L, what is the value of B sub L here? Okay, so we know that B sub P, okay, B sub P is actually, this will be the sine, the maximum, okay, value B sub P, okay, which is the sine of 180 degree over N. Okay, so this is the value for B sub P. If you want to get the value of B sub P here, that will be the peak value here, sine 180 degree N. So therefore, if you are to solve for B sub L, you only take this point, and the other connected coil here are in hanging position, so they will not be counted in the loop. So B sub L here, actually you have here BP and BP, so you are to add the angle, your phase angle. So therefore B sub L is actually twice the BP sine 180 degree over N. Okay, so this is how you change the line voltage to the phase voltage. And for your currents here, we know that IP goes through here, and it is also your IL. So therefore, in a star connected system, your phase current is equal to the line current. Okay, so by the way, we can have we can further deduce this one, this equation. Why? Because sine 180 degree, if you have a fixed value for N, you just substitute it, and then you can get the value of this one multiplied to 2. Okay, so you can actually deduce that, specifically in a 3-phase system. Okay, so this is for the in-phase star connected system. How about if you are going to connect the polyphase or your in-phase, and you have a what we call mesh, okay, mesh connected system. Okay, it is like this one. So you have this coil and another coil here, and another coil, and another coil here. Okay, and the point here, it goes out. Also the point here where these two coils are connected, it goes out, and the point here, it goes out also, and this one, it goes out. Again, same notation, we use V sub P for the phase voltage here, also at these coils, and we just have this point also for our B sub L. So let us take this one. So the point at these terminals are B sub L. And if you will notice, if we will consider this coil, there will be a current that is passing to that coil, and we call that as I phase. Okay, and the current that is in this terminal is what we call the IL. So what is the difference between connecting a coil or connecting your system to the difference between the star connection and the mesh connection? In our mesh connection, what is the same are the voltage. Okay, so you'll notice that here our voltage in the star connected, the current at the star connected are the same. So your IP here and IL. Here in this case, you have your B phase equal to here to B sub L, the line voltage. So also this one, B line here, B phase, B line, and B phase also the other outermost part of the drawing, circuit diagram. Okay, and your current, you will notice that your current, if there is a current here, okay, this passing also to this point, you have an IP, you make a Kirchhoff's current law at this point, you'll notice that IL is actually the summation of IP plus IP. So that is twice IP. Okay, but our IP again is the maximum value I phase, okay, IP, which is sine 180 degree over N, and when you substitute that here, your IL will be twice IP, okay, sine 180 degree over N. Okay, so this is how we interpret that one. And for your in phase power formula, or the power formula, okay, okay, N phase, or the polyphase power formula, we have this equation. P is actually the multiplication of your phase value for the voltage and the phase current times the number of phase. So that is N B sub P I sub P. And we take here since we have here a power factor, so we multiplied it by the power factor cosine theta. Okay, so this will be the formula that we are using in solving for the N phase or the polyphase power P. Okay, this is the power formula. Okay, so these are all about the phases. I do hope I have contributed something or added ideas to your learning desire. So thank you so much for watching this video. I hope that you will share these videos to your friends and like and subscribe to this channel. Thank you so much and God bless.